In today's video, we will discuss securing zero trust access in Kubernetes. AppGate SDP provides dynamic policy control and granular secure access for Kubernetes by automatically injecting our sidecar client as a container. When microservices need to scale, AppGate SDP sidecar clients automatically deploy to match the required scale. Secure zero trust access is granted at the container level within a pod to provide microservices connectivity to resources outside the cluster using a unified policy framework. We do this by leveraging the AppGate SDP Kubernetes sidecar client. It is designed to map to a pod within a cluster, thus enabling secure access from a microservice out to external resources using our micro-firewalled gateways. This is a simple illustration of our demonstration setup. We will use a locally deployed AppGate client running on a MacBook to SSH into a particular Linux server running in Amazon that has Docker installed. This Docker Kubernetes kubectl deployment will then provide a launching point to reach into the Kubernetes pod that contains the sidecar. This interaction can also be achieved with local tools. In this particular example, we will demonstrate our ability to use the sidecar client to control traffic from a container. This container has BusyBox, a utility application, installed on it and resides in namespace demo2 within an AWS Kubernetes EKS cluster. The traffic will be sent out to our EC2 resources that live in AWS EU West 2. Our external EC2 resources will be two web servers, CorpApp 1 and 2, that are sitting behind our AppGate protected gateway. Access privileges in our environment are being controlled using various metadata tags. We're most interested in the tags associated with K8S2. You can see in the AWS console that CorpApp 1 and 2 are currently tagged as dev. So what this means is that when K8S2 is tagged as dev, then our AppGate sidecar client is granted access to that resource. To test this access, we're going to utilize kubectl to connect to the Kubernetes BusyBox and then interact with that operating system and tell it to watch a wget command to the CorpApp 1 web server. This command will perform a query to the web service on that server and pull back the top 20 records from that HTML page. This will prove that our sidecar can connect to that destination on the network. Here you can see we're outputting the HTML code from that destination, and we're refreshing it every 2 seconds. So we've proven that we can use the AppGate sidecar from within a pod to reach out through an encrypted tunnel to a gateway in AWS London to access a specific web server. Now we will see what happens when we change the tag for that CorpApp 1 server. If we change the K8S2 tag to prod and we toggle back over, we can see that we are now unable to access that web server and our polling command fails. This is because that tag no longer meets the access criteria for that sidecar client. Likewise, if we reconfigure the tag back to dev and check again, our access to that web server in AWS London is restored. AppGate's SDP solution can secure access privileges to your critical applications, regardless of where they live, and can now enable you to set granular conditions and policies to control how microservices are utilized in a containerized setting by leveraging the AppGate Zero Trust for Kubernetes solution. To learn more, please go to appgate.com.